Hi guys, so we just find the transfer function of this particular system. So the first thing you should know is that the sum of applied forces is equals to the sum of opposing forces. In this case, this applied force and opposing forces are this and this, as well as the mass itself. So F of t, which is the applied force, is going to be equals to the force of the mass plus the force of the damper, damper plus the force of the. So for the mass, it's going to be mass times acceleration. In this case, acceleration is differentiating displacement twice. Plus, this is dampening force, which means it to be the damper. This is supposed to be FB, force on the damper. So in this case, the force on the damper is going to be FV, which is the damper itself, times velocity, which is differentiation of displacement, plus the force on the spring, which is simply just K, the spring, times the displacement. Now we simply take the Laplace of the equation. For the mass, you can see it's d square x dt. So we're going to be picking this one. Ignore all initial conditions. So it's just going to be m s square x s. That is equals to f of s. The Laplace of f of t is simply f of s. So it's going to be f of s. So at this point, it's f of t. Now it's f of s. Plus this is at this point, ignore our initial conditions. So it's just going to be FVS XS. We're not dealing with F, we're dealing with X plus KXS. You can simply see that here. Now you can substitute out XS because the XS because sorry MS square plus FVS plus K. So xs over fs, which is the transfer function, will be equals to 1 over m square plus fvs plus k. This is your final answer. Thank you for listening.